Hello and welcome to our wonderful, great webcast about Dynamo and how we can actually boost our productivity within Revit. What we want to convey in this webcast is that Dynamo is actually a programming environment, and we also, what I especially want to break in this webcast is the fear of programming, because when you go to develop an application, very often we are a little bit on distance on doing some programming, do a little bit of a hacking here and there, and I actually especially want to really show that the Dynamo is actually very, very easy and very, very simple to learn and can be very productive. Very often when we go to YouTube, we actually see that there are a lot of freaking buildings, a lot of freaky designs, and with a lot of big nodes, and we actually don't understand how this actually works together. So I actually want to really point out on the logic, and I really want to point out how these nodes actually work together, that you actually can learn it. We probably would agree that nobody is actually learning a software, especially a programming language. It's like a language what you have just within an hour, obviously, but I also want to give you an opportunity to see how you actually can learn it so that you actually can help yourself. The reason is that the Dynamo is not an environment which is always straightforward. You actually need to work a little bit with the logic, and you need to have some logical thinking behind to do so. Probably the one or the other one already starts with has some anxiety questions popping up, but don't worry, just watch the webcast, and we have a handful of examples I can show you then how they actually relate and work together. Cool. So this is what we want to do. Let's quickly tell you a little bit about A2K, where we find the Dynamo plugin, what's actually required for Dynamo, and actually how we can learn it. And this is, of course, the main question, what we want to look into for that. Cool. I got a little bit about A2K. You probably have heard about A2K around, and it's a big merger from AC Systems, Caracat, and ADA partners. We have about 150 guys around, and yeah, we try to be the technology advisor and try to help you with some support. And I have seen that with the one or the other one of that in this, we probably spoke together on some support, and was actually pretty cool. For instance, and yeah, you do some great work, as well as we try just to help you and to help and to support you. Good. So I actually don't want to ink here computerly. I just want to go to the next slide. So it's a little bit about me, what I'm doing within A2K here. I'm working as a technical consultant. I have a structural background, structural environment. I'm graduated in business and engineering a while back with a major having in PLM, means product lifecycle management, and obviously I end up doing building information modeling, while my major background is of course the structural as well as the architectural with it. But I was sometimes invited to speak on some conferences, which is cool, but I'm actually commonly here to develop and workflows and to answer some questions. Good. So where do I find actually the Dynamo plugin and where it's actually available? So Dynamo is by default actually part of Revit 2015 R2, and so when you install this, that automatically Dynamo is basically being installed, and I believe that the one or the other one had maybe a little bit of play and go with this, but probably you didn't find yourself in place, or you couldn't really connect maybe with the environment. And I mentioned this is actually what we wanna break. The whole environment about Dynamo is that it is open source software, and our Autodesk put a foot into it and is supporting it. In the past, you probably have seen Grasshopper for Rhino, but Rhino and Grasshopper, they just deal with geometry. Dynamo became a whole programming environment where we actually can not only deal with the geometry, but actually also with data. And so this is, of course, a huge benefit, use advantage for that. But if you want to know a little bit more about Dynamo, go to dynamobim.org, and it's a very, very wonderful, cool website, and we find also a lot of support. And I feel over the last observing this technology for the last 5 years, and over the last year, or the last 2 years definitely, the whole documentation actually did grow, and which makes it very, very nice and easy actually to access. But to mention, focus on Dynamo for Revit today. Dynamo is also available, for instance, for Robot. We see this on the left top. Dynamo is also available actually for Inventor for that, even for Navisworks. There's a development out there, and also, for instance, for Maya, what I found. So it's an environment where we actually can deal and can communicate with the computer what we actually want to do. Dynamo also exists as a standalone application called Dynamo Studio here, and you can just Google it basically, or go to the Autodesk website and you find this. And so if we want to install it here, when we install Dynamo Studio, just go to the website and look it up if you want to do it. Good. So next question is, what is required actually to run Dynamo? How do I actually get into the realm of the whole logic, the bits and the bytes, and what's actually all about? So when you do programming, we actually don't need to have the huge killer machine of computer, just a standard Z440 environment. What you probably use for Revit is actually 3 times over the top, and it's actually pretty good and does the job. The tricky part when we do programming is actually the calculation, the number crunching, or we call it also the compiling of the logic we currently have set up in the back end. But it's not, if it takes maybe half a second longer, it doesn't worry us, because by the end we actually want to create something. So let's have a quick look a little bit into the logic and have a little bit of look into the whole computation environment. And I try now to guide you, to lead you from a familiar environment, basically to apply this logic to start getting started with some simple stuff. If you have your laptops available where you have Dynamo installed, just bring it up, and hopefully that I can do the exercises slow enough that you maybe that I can set you basically on fire and that you can actually follow for that. Good. What's the familiar environment? We know that when we create families, that we can set, that we can influence our geometry with parameter. Also in 2014, for instance, was invited on the AU in Las Vegas to present here about doing some structural analysis within the family, and we see, for instance, that we can add a lot of formula. However, this type of formula, what we have, is actually just on a Microsoft Excel level when it comes especially to the flexibility. But at least it gets us there, and it offers us a bit of a freedom and a flexibility actually to work with these families. On the other hand, going totally crazy, we know that in Revit we can add on macros. Macros are programs similar like we have to find it in Word as well, we find it in Excel, where we actually do some real coding work. So really we tell the computer what we actually do, what we want to do. We can write our own user interface, and we can really interact. And so the key is just that this kind of language you actually need to learn. Dynamo is a little bit of a hybrid of this. So we do something visually with the geometry like we would act in a family. On the other hand, we have the options to code here a little bit. And I think exercises 2 or 3 is something where we talk a little bit about code blocks. Cool. So this is our environment, if anybody. So, but don't worry, we don't need to have this environment. We are not working with classes. We are not dealing with a lot of imports or so. So this is not what Dynamo actually is. With Dynamo, we actually keep it visual, and when we install it, we find it in our add-in area, so we don't have to set up a big complex macro or so. Now we find it in the add-in area where we have just our Dynamo, and we find, for instance, here on the right-hand side here, we find here a little bit the area where we see actually our modules. By the end, it's maybe you play a little bit with Lego, you have different blocks, and with these blocks, you actually build something up. To explain it, let me maybe grab a bit of a different example. And I don't know if anybody of you remembers maybe these net puzzles, where we actually move these blocks around to create actually a picture. And these are the same type of muscles in our brain actually we need when we actually deal with Dynamo. So when you have a little bit of a passion for logic games, when you have a little bit of a drive actually to do a little bit computation logic, if it really fascinates you. So this is this kind of maybe new game working with Dynamo, what you can look into this. So this is actually, this is kind of the key. This is kind of the entry door to do some logic with Dynamo. Good. So how can we actually learn Dynamo an easy way? Unfortunately, I can't offer you a pill. You can't order a pill. We need to learn it the hard way. This means we need to read some documentation, but the best thing is that you learn it by doing, actually. And because of when we use Dynamo, when we write something, we always actually need to have a problem prior. We use Dynamo to solve problems. You just use. You can't just create a logic without any purpose. That doesn't work. So we first need to find out about the purpose and what we actually want to achieve with it. Okay. When we look into the web, we find out another website, for instance, here, Dynamo BIM, on the website that they actually have a huge documentation with a lot of references, and it's really very, very nice and easy to look this up and also to follow the examples. I'm not making up some own examples in this webcast. So what I want to use, I'm using the examples actually from their website. So at any time when you actually want to go there, we actually find the same examples. You actually can do it, what we actually do at the webcast. Also, they have a lot of video referencing, which actually guides you through step by step by step through the same thing what we actually do here. So why do you want to watch this? And basically, you get a bit of a compact overview what Dynamo is actually about. So I want to set you on fire for this. Okay, so another website, what we find is dynamoprimer.com, which is out there, and has some really, it's a nice cool addition to learn it, and especially when you want to look up something. I'm using this myself as a reference manual because we are solving problems. It might not be that you always know everything by step. It's like you develop a design, you have different sketches, you have different changes, and the same thing it is also with the logic. So that you, for instance, want to sketch here logic. Good. If you're interested, we also offer a Dynamo course here from A2K. We have one in April here coming up if you want to go there. They're in Brisbane, they're in Sydney, and they're in Melbourne at this point, at this stage. So these are these 3 dates. Just look it up. And what we find is, and what we actually rely on is also on the some of these examples what I've shown you from the web before, a little bit of the examples what I want to show you here, where we actually can rely, because important it is that we actually start practicing, start doing it. Okay, so we have a couple of live examples I want to run through with you to guide you with how the whole logic actually works, but what the idea, what the purpose of this is, and when we want to work something. I just wrote down here a couple of questions. When you want to work on with Dynamo, when you achieve something, we should ask ourselves a couple of just traditional standard awareness questions. So, what is actually the challenge? What do I actually want to do with it? Do I just want to learn it? Do I want to be familiar, or do we want to do a solo optimization? Do we want to exchange the families? So what is the issue? What do I actually try to simplify? And because it doesn't make much sense, wouldn't make much sense just to jump wildly on Dynamo, because Dynamo just experienced currently a big buzz. Ask yourself, why do you actually want to do it? Then you actually can, that you see actually this problem sober. So what input do we actually have, what input requires? And so I know, for instance, my families, and I want to change my families. For instance, I want to build and move or rotate families. I need to have in my design a specific flexibility to solve, which I want to optimize, because I see some cost savings around this. So these are the questions what we actually want to ask. So what modules do we use, and what do I actually need to do with my data? Good. And just a little bit upfront, because we are dealing with some programming, with a programming environment, a couple of basics we actually also find. Similar like we find it, for instance, in the families, we find, for instance, an integer. An integer is a number like 0, 1, 2, or 3. We have a double. We have a double has also a comma at the end. A string is something which is a text. And a list is called, for instance, an array. So when we look, for instance, for an array, and it can be, for instance, that we have a one-dimensional list. It can also be that we have a two-dimensional list, and commonly we find this here in with the brackets. If you do some programming already, like C# or Java or something like this, everything is pretty simple. Everything will be basically pretty easy for that. Good. So I have somewhere here my Revit up and running, and we obviously see a little bit the past projects, what I want to a little bit demonstrate. So what I will do is now, in my case, I will just find here the families, go to my standard new conceptual math. When we want to do some Dynamo, the easiest way is actually to start something conceptual and just to have a little bit of a play, let's say with a couple of points. Why are points cool? Why are points important? Because, well, geometry is being defined through points. Good. Let's go here to the add-in. If you have Dynamo installed, you should probably, I don't know if you have also the amount of add-ins, what I have to carry around here. But we found this, for instance, here under the visual programming, where we find here in visual programming our latest Dynamo, actually here Dynamo 09, which is kind of, I think, a couple of days ago, and updated to it. And now we see here our Dynamo window coming up, popping up. So it's you see it's actually like an own independent application here, but it's connected. It actually works together with Revit, which is actually pretty nice and which is pretty cool. Good. So to the whole user interface, to the whole environment, just to warm you guys up, it's like any other application that we obviously have something new. We can open something up and we can also save something. What might stick out here that we actually can export our workspace to an image. Remember that we are dealing with nodes and some visual nodes, and obviously you want to save this somehow. The easiest way actually to save this is obviously an image. Export the model to STL, obviously then we can 3D print it immediately. Under edit we find everything around copy, paste, and that if you want to create some nodes or so, that we can, because we can also create our custom nodes, which means when I have, it's like a family, when I want to reuse it the next time, and I always have to reuse it on every project, why not create a custom node and you can reuse it next time. Because we are dealing with some visual, we see here first of all that we can use our mouse wheel like in any other, like within any other CAD application, that we actually can zoom in, zoom out, and we can actually also pan here. What we see this here as an example with when we drag actually with the mouse wheel. So with the middle mouse button, that we can actually drag this around. Good. We can show our connectors, and we can also use some curves or some polylines or whatever you love. It's a bit about this look and feel for our Dynamo. Good. Background preview, if you want to show the grid or not, is similar if I want to show the grid in my environment. I would suggest to keep it on because it helps us a little bit with a 3D depth, especially on the screen, because the screen is still 2D. Then we install Dynamo. When Dynamo is being installed automatically, we find here that we have some basic core of packages. So in Dynamo, within Dynamo, we are dealing with packages. And the packages is like some essentials you actually start, like you would buy some potatoes, some tomatoes, where you start to prepare some meals. And okay, so these are like some essentials where we utilize these libraries. We utilize here in Dynamo. And by the way, there are a lot of different packages all over the web. We can manage our packages, for instance, what we have installed. We can also publish a new package, and we actually can also, for instance, as an example, search here for a specific packet. It's kind of just trying to connect with the server and just wondering if this actually works now when I'm broadcasting here. But that came on just in the last second before I wanted to shoot it. So we find here a lot of different packages, and sometimes it's pretty cool to actually read through what others in the web. It's an open community where they actually program, because it's actually it can save a lot of time. Good. We have here a couple of more settings about our number format, how accurate we want to do it, about our render precision. I just keep it quite low here, just because we are broadcasting as well. Good. And then, of course, we have here our big help. It's still under development, so when we have here a bug, like any other software, sometimes has bugs if it happens, and then we can report this, and then we have also some samples. So these basic samples are actually installed by default. So if you're dealing with some points, do some math, some simple math, we actually can browse and actually can join them for that. We can also import and export some stuff as we see, and we can also deal and connect, for instance, here with Revit if you wanted to here and see a couple of examples for that. Good. So we see now that we have Revit in the back end, and obviously our nice environment. It's cool, it's great, works nice, and So I actually can switch here between Revit and actually Dynamo, and we see actually that Dynamo always stays on top of Revit here, as an example. So it might be maybe worth to make the Dynamo a little bit half of it, and then basically Revit when you have both, or you can actually run both on 2 screens. I commonly run that both on 2 screens if I ever have to face a challenge I'm using Dynamo for. Good. So how to start something new? Obviously, we can guess here. We find here a new button. So all what we need to do is we just quickly type into new for that. Good. So our menu here on the top still stayed the same. Still the same stuff like what I just have shown you before. Just on the left-hand side, we got basically our library. With this library, and I can pretty browse through here, these are the libraries we are actually dealing and actually working with. So here are actually our Lego bricks. Here are our modules. By the way, I'm just opening here Firefly. If you don't find Firefly now on your machine, don't worry. It's just an additional package I actually have installed. Everything what we do now is here, it's just total basic. What you can actually do out of the box. You actually see that you can connect it even with Illustrator, so some cool stuff around. If you want, somebody asked me what other packages do you prefer, what do you think is good? Lunchbox is pretty cool, and Firefly is, for instance, pretty good. Currently playing a little bit with the Rebar import here. I have 3 bar packages here, and yeah, where we can actually automate some reinforcing. And some others are also some favorites, maybe if you have raindrops, because there's some nice cool stuff out as well if you wanna deal and work with. Good. So here, as you see, so how does this now work? Because this library on the left-hand side is very, very complex. The easiest way is actually when we look for a library. And if you want to follow these examples on the screen, what about this? It's just type in, for instance, I want to create basically a point coming up, and you see it takes a little bit of a while because there are a lot of points out there, and we have a lot of options to create points. The easiest and the simplest way is actually, for instance, here a point by coordinate at this point. How do I get it now in my workspace? I actually just click on it, and obviously we see here a point by coordinates. Please be aware, we see here on the top point dot by coordinates. So this reminds us a little bit on some programming. We have a couple of notes. We have also notes we actually can rename if we wanted to, but in the programming language, it's like basically a method. What we have here, where it calls actually upon this method. And we see on the left-hand side, we see here X, Y, and Z. Obviously, this X, Y, and Z must have something to do with an input. And on the right-hand side, we actually create the point on the right-hand side here, what we see. Good. We see here a tiny line here underneath. When I hover with my mouse over it, we actually see the output. Currently, we get a point here on X0, 0, 0, which is pretty cool because we actually see here this point on the back. So this is my node here. This is called as a node. So on the right top, we see here a little bit our traditional navigation bar area where we can switch, for instance, from the geometry. And you see now, hopefully, that the nodes are a little bit grayed out. And on the right-hand side, when I switch back, they can switch back to the node. So again, we can click into the geometry, and then we can also click here into my logic again. The navigation bar is what we have here. Obviously, we can pan our nodes around if we wanted to, but we have just read before that we can actually also use your middle mouse button. Good. So obviously, the zooming does not work for the geometry. It only works here for our nodes, and I'm just using here my wheel where we can zoom in and can zoom out. All right. So when you have to zoom out this way, then you probably have a crazy logic. So don't model this way if you just have a couple of handful of nodes. The best thing is we just zoom a little bit in here, and then all is good. Good. Let's switch, for instance, here to the geometry here on the right top, and then, for instance, here there's a little bit, and then we can also make use here a little bit and orbit it a little bit around with the left mouse button. So because I'm using a Wacom tablet, I want to do the things a little bit different here. Sweet. Good. And then we go back. So we see basically here the point. Great. So how can we influence this point? So how can we influence this point? Obviously, we need to have an input for the X, Y, and Z. So the easiest one is, for instance, here as an example, to put actually a number in. So we can just click here for a number, and we see that the number input basically comes up. Also, if you want to just being straight, we can also type in something like here, some integer, where we find also some number sliders, because we have seen that we want to add some flexibility. So a lot of the schematics, what you have seen, they're not just developed on a rainy Saturday afternoon, so there's really a bit of a brain power was happening from the one or the other one, and there are some really amazing designs people do. Good. So we want to go actually here just with a simple number at this point, and here I'm just basically click here into it, and obviously we get a number here. I can define and specify here a value. Let's say we want to maybe do something like 3 at this point. Great. So, however, the point actually we have here on the center didn't move. There's actually nothing happened. This is the reason, because we actually need to connect now these nodes with the point node together. So I need to create a bit of a logic here, and I can create this just here by click, and we see now how here it's like a wire. If anybody plays synthesizer or so, it's like you wire different synthesizers together. You wire different, like your PA, your CD player with a PA. You basically, if somebody still has CD players around, but you wire them basically together. Same thing what we do is here as well. So we take the information basically being out here, and we just put it, for instance, here into my X. So crazy, wonderful, cool. And so the 3 obviously is my X here. When I click now here on my point, I see obviously we create a point in X3, 0, 0. And we saw actually that the point actually did move. If I want to release this node, I can just click again here and maybe connect it to somewhere else, and we actually see that the point now did move here into the Y. So if you follow this exercise and you have never touched Dynamo, so basically you have the first cool schematic here, and hopefully you want to go wide. So what we also can do is we can actually connect it basically to all 3 if you wanted to. And this means that we have in 333 actually our point. Good. Another note might be when you want to, for instance, here influence geometry, we can literally program anything and everything. If you look out, want to change any families, if you want to change, if you want to develop any cool masses, so everything and anything can be basically created here. So it just relies really on your fantasy and on your freedom. So let's go, for instance, here. Let's look as an example. Just type in slider, and you find here on the left-hand side here a number slider or also an integer slider. We have seen and heard that integer are full numbers. So I just click 1, 2, and 3, for instance, here as an example, and bring this up here, and bring this, for instance, up here, and bring this, for instance, up here. Good. Please allow me that I zoom a little bit out here, and then I have here my point here together. And all what I need to do now is here bring up, for instance, the slide, because sliders are cool to work with, because when we use Dynamo, we're always after flexibilities. And sliders help us really to be very flexible. So I click, for instance, make this the X one, the middle one, we go to the Y, and the bottom one, we go here to the Z. So we see how we actually build up the logic. Here on the top, if I wanted to click on it, just to keep life simple, I can actually rename it. So here I want to slide, for instance, my X. We can just double click on it. For instance, we make here a Y and accept it. Come on, be nice. And here on the bottom, we just double click on it, and how do we want to call it? Make it basically here a Z, and actually accept it. Cool. So, and now when I, for instance, here slide here, we see actually that my point is possibly moving here. I probably need to do this a little bit slower. And we also probably see that my slider is just driving my point totally crazy out of the screen. And this is where also the slider becomes very convenient, because when I open this up here, we have here the options to have maybe here a minimum and a maximum. So let's see, for instance, you want to go maybe to 10, and we just want to have a step of 1. For instance, also here, let's say we want to have just 5 with a step of 1. And here, for instance, for the Z, we want to just go to 3 and have a step of 1. As an example. Okay, so I can basically close this here just to win a little bit of some real estate on my screen. And then, for instance, we can actually drive here my point straight and have a bit of a play. This point, of course, can now be used to drive any kind of geometry in any way actually we want to. And we see, for instance, it going up and going down. You can play this the whole afternoon. It just makes a lot of fun watching it. You have the authority over the computer. Okay, great, cool. So another thing is, of course, that sometimes we cannot only rely, for instance, on the sliders here. As soon as we actually select here a node, we just delete it. Let's just have a little bit of more fun, for instance, with points, because I want to show you a little bit around what you actually can do with this. We can just double click here, and then something called a code block comes up. So don't worry about code blocks. That's all easy. It's just that we can program a little bit of a. And what we just had here is that we want to, for instance, create a simple myth. Let me call it a simple myth just with a simple line. And just type in, for instance, 1 and then dot dot. And then please trust me that we do maybe a hash of 10. And then we do a dot dot 2. And because any computer language, so if you want to show off on a cocktail bar, just remember computer language, we always have a semicolon at the end of the line. This is what we need to know. And so also here, we need to have in our code block a bit of a semicolon at the end. Good. Because we just entered here a couple of numbers and we just have a bit of a play, we now connect this just to be a little bit simple. Good. So we connect this here. You see already that a huge list is coming up here. Bum, 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 bum. Right. So, and now what we see is that we actually created about 10 points with the here was the distance actually of 2 while we started in the area of 1. So the first is 1, 1, 1, then 3, 3, 3, then 5, 5, 5, 7, 7, 7, and this always goes up. Obviously 10 around the number. Okay, good. So these geometry points, and we basically, when we click down here on the list, we see here how this influences this actually. Good. So when we click here under my geometry, we can use here a right mouse click with a node. So you go to here to the points, right mouse click, and that's, if you please stay open computerly, thank you. And then we find here a submenu called lacing. We have 3 products what we actually can compute. The shortest, which is very, very simple, which means it creates just 10 points. The longest ones, everyone with everything. We don't have enough input for everyone with everything, but a cross product is basically pretty cool. And all of a sudden, hopefully it drives the one or the other smile maybe in your face already, that you see when we create a cross product, we can actually create a pretty cool mess here in the backend. So what I will do now is here just zoom a little bit around, and we see that we have actually 10 with 10 points actually connected, and I pure theoretically just, yeah, if I want to create some nice cool geometry, we probably can assume and imagine that we actually can create here some nice cool stuff. Good. So just basically with these 2 nodes, we actually can achieve something pretty complex for that. Good. So having this one is now around, but this is not enough what we actually want to do. We actually want to look into a full example. Just of the feeling, maybe we want to look a little bit into some solar orientation, because solar orientations are cool for that. Great, good. So if you want to save, by the way, your Dynamo file, you actually can do this here, the file and the save. So if you did follow just this exercise, just as a DYN, just save it, my first file. Commonly, when you learn some programming, we always have hello world or something what you save, but here we have my couple of thousand points here. Sweet. So let's close this here, that's all nice, and let's look maybe into maybe a different environment. So what we can do is here, I just probably would need to close quickly my Dynamo. If I want to change this, no, I don't want to do so. And we just can basically go into a simple environment, and all what we need to do in this environment is that we actually make here in our 3D view, for instance, we want to make maybe here our sun basically available for that. Yes, cancel, sorry. Something happened here a little bit, and I quickly need to tidy a couple of things up here. So what's that? That's my environment here. Sweet. Nice. So we just prepare a project where we just have maybe here our sun available, because we want to create some panels and they are actually following the sun. Here as an example, because everybody's always talking about this. So we need to go to our add-ins after we did so, and we find here under visual programming again our Dynamo. It's still there, just fire it up in a second, and then obviously we need to create something new. So just open up your Dynamo, and then we find here which is new. Cool. So when we want to deal with some sun and some sun settings, obviously we need to find some classes called sun. So what we can do, just type in, here's just sun, and then set Ting. And we find here a couple of sun settings popping up. So it basically, it looks into Revit and says, what's actually the sun setting what you actually currently have up there, mate? Okay, where's the sun actually? So just click into it. So obviously we get a sun setting. A sun setting, because it reads something out, doesn't have an input, what we obviously notice here on the left-hand side. And currently, we actually see here also on the bottom, when I go here to my sun settings, that it's currently in session. It's still, it just gives me a little bit the area where the sun settings are. Good. So the sun settings, we want to actually convert into a direction. So we want to figure out in which direction this actually goes. If somebody asks how accurate this is how accurate a computer can be. Nobody recently measured exactly the distance between Earth and Sun, or at least they didn't came back. Must be pretty warm up there. Maybe they're sitting up there with a cocktail on the beach. Sweet. So what needs to look on there is called a node called sun setting star, and we actually look into a sun direction. So sun settings, and then sun direction. And obviously, when we use some typo here, then we have a little bit of an issue. So calculates the direction of the sun. So click just look into it. So now we see here that we can actually connect here our sun settings to the sun settings for that. So what's of course the tricky part? How do I ever know all my nodes? You probably will never do. If you want to fill up all your nodes, I think in 2010, 2011, somebody once did it, but it was actually a huge chart of nodes which is around there. And if you would do all nodes now, it's probably you would fill the whole wall of a whole office. And you probably have it in print font size 6. So you will never find it. You will find that you have some nodes you have some preferred nodes, and in case when you hack and develop this logic, you will go maybe into their web, and they still will stimulate you to use some nodes there, okay? So it's pretty common. So for instance, you want to connect here our sun settings with our sun settings, which gives me obviously a vector. Good. So after we have our sun vector, we actually can rotate and twist anything and everything we want. We just would need to create a bit of a geometry for that. Cool. So having, for instance, a circle by center point radius might be maybe fun, because when we have a circle with a, basically when we have a circle based on a center point with a radius, we actually can use this maybe to create some panels based on some polygons. We actually find also this exercise there online if you want to look for this. So obviously we want to create a little bit of a circle. So rather now thinking we create a polyline with 4 lines, we actually want to drive everything with a circle. So how do we come up with this? No, well, it's a little bit of an experience or a little bit of a stimulation we actually get from the lab where we do a little bit of a hacking, a little bit of a research. So I have done this for us already, and all that we need to do is we just type in, we actually want to produce a circle, and here we find here as the second one by center point radius normal. Why with a normal? Because we actually want to orient, we actually want to move here our circle. So I'm just clicking it here, and of course we have another node which brings up. You see how we actually compute this this whole logic. We need to play a little bit of Sherlock Holmes, how we're investigating this, and then we can connect, for instance, here our vector basically with our normal, and then what we see, for instance, here already that we have here a point around our origin. Then we see here, probably let me zoom in a little bit here. Come on, a little bit nice here. So we see, for instance, here a circle around the point, and all of a sudden also that the circle pushes towards one direction. What we can do. So if we have here on the left bottom a tool called, if we want to run it automatic. We can also run it manual. If we want to set this whole software here to manual, then I need to do the run proactive, basically. So the only thing is, when I have, for instance, very complex logic, I suggest to keep it on manual, because as soon as we program, the computer is a little bit prone to crash. A computer sometimes crashes, as we know. A computer just runs by chance, actually. And here, then please set it maybe to manual to work yourself through. In our case here, we can just keep it on automatic. And when you just fire up Dynamo, I think it's by default. I don't nail me, but I think it's on automatic. Sweet, cool. So I have here in the back still my sun, and when I, for instance, now move my sun around, then we see that the circle basically moves, rotates, twists, and for instance, go up here a little bit, and we see that probably takes a bit of a second till it updates, that we find here our geometry in the back actually following with this. So the logic and the geometry and the connection between Dynamo, our logic, and Revit actually works at this point. And this is just basically with a handful. By the way, if you use this kind of logic, create maybe an own node if you wanted to, or just create the sun logic and reuse it with your next project. So good. Let's move this a little bit away because we want to actually use the circle to create something. And for this, what about using a polygon? With a polygon, we can simply convert basically a circle into something square or hexagon, whatever we love. And then we want to simulate a couple of panels, solar panels following on the top of our roof, basically where the application is what I'm actually running to. Then we could do this. So this would be that we need to type in polygon. Obviously, we want to convert, and let's say maybe a rectangular polygon. Let's say maybe something like rectangular. Rectangular polygon comes up already, and then basically we click on this. Fantastic. Good. We want to have some number of slices, hence what we simply can do is just either code block, or I use maybe a number node, and I just type in, for instance, here the slices. My circle I connect with circle again. So you see it's actually playing like Lego, where the blocks actually fit together, circle with circle, number with number, normal and vector together. So that's actually pretty cool. So the question is now, how can we create a code block? Remember, it was just a tiny double click here. And for instance, we just do not a 34, this might be a little bit heavy, but let's say maybe a 4 at this point. Good. So, and then we just click some on the outside, and then we can actually connect this here with our number slides, and then we actually have here our 4 for that. Good. It's nice when we have our for polygon, which is cool, but we actually also want to deal with and try some, I want to create a surface. So we just need to look then basically in a surface is the next step. It's similar like you would do some meshing first, a bit of a sketch. We kind of produce the sketch, and then we just kind of move our sketch, and from a sketch we create then a surface. So what do we kind of surface? Let's say for instance by patch. So surface by patch is my favorite one. So and all what we want to use here is that we go for instance with this polygon to the closed curve. Okay, this might be a little bit of a tricky one because circle to circle obviously was shown here, circle to circle, but here actually I need to connect polygon with closed curve. And so when we for instance here click on it, it's not necessary that it's obvious that we actually can connect it, but trust me, we actually can connect this. And obviously we clearly see here a little bit of a surface. Good. So when I now move, for instance, my solar settings, obviously we see that my surface actually moves up, twists, and rotates in all directions. Good. Just to have one solar panel on the roof is a little bit boring, and so what we may want to look into maybe to add a little bit more onto that. And what about this? Let's create maybe a list with a lot of different center points. And what we can do is here, like we did before, we just start maybe with adding a couple of sliders. So you see how we actually develop the software. Step by step, we touch ourselves through the whole thematic, through the whole area, through and basically harnessing and let our creativity actually bubble up to produce the software, the logic for that. Good. I want to have maybe, so this means I want to create basically a list of points, and obviously we need to create points. We had this already using, for instance, the points by coordinates, and then we can just, for instance, here do maybe click point by coordinate, come up here. Thank you. You work nice today. Good. And then what else? And so we have here, for instance, one point, and then we go here with a couple of, and then probably we need to have a radius as well here that we play and work maybe with a little bit of a different value here, to have maybe here a radius. And we can, of course, again, use a code block like what we just did before. But when we use, for instance, here just an integer, or theoretically, maybe we could also, it's just maybe just a number slider as an example, then, of course, we can actually connect here our radius as well. Good. So now open this up a little bit, because we have here maybe the size of our solar panel. We actually want to have a bit of a play. Let's say we want to maybe limit it by 2, and the steps shall be maybe 0.1 here. So we see, for instance, this. So when we now slice this a little bit up here and spice this up here on the bottom, we see actually how my panel actually goes up, and my panel also goes down here on the bottom. Good. So then we just need to have a center point. My center point, I actually want to influence here with this logic together. So, and all I need to do is now just create a crazy mess like we just did before, and we have a lot of solar panels on the roof actually now following our, for instance, following our sun, what we actually have here in Revit. Cool. So then we can do here, for instance, just here with the X and the Y if we wanted to go there. And by the way, we can actually also do here, for instance, work either with a code block. Means, for instance, here I think 4 as an example times 4 as an example, and then we click, for instance, out here. We see that we have a summary of now numbers here, for instance, that technique, and we just connect them. However, this is, if you know that we have 4 by 4, then just basically connect this here with the X and Y if you wanted to. Otherwise, we can do something different. Good. So let's unconnect this here quickly, and I have something different prepared. So we have a point by coordinates already. Then we want to create a list. We actually want to complex, so we actually want to create here an array. This is a list.create. Would be nice. Very good, thank you. So we have basically a list create, because I want to actually show you that we can also have here multiple points here coming together. We create basically here a list to my center point. At this point, we get a little bit of an input error here just to demonstrate this as well. Why? Because yeah, the list is basically pretty empty. So that's why what it kind of complains here. If you want to copy something, you can just select it, and then we actually can do a tiny copy paste here. So just, for instance, for these 2 coordinates, just do a simple copy paste if you wanted to, and then we, for instance, want to connect here our 2 points, 1 and 2 together. So, and then of course, last step, as you see how we build up this logic, is that we actually connect here our list to our center point. Cool. So now we actually want to apply a little bit of a code block a little bit different here, because we want to be a little bit flexible. What about these? Let's just create maybe a code block just to demonstrate this as well, to warm you up a little bit. Good. And what we type in here, for instance, is that we have here, for instance, 0, and then we start with a dot dot, and then let's say, for instance, we count in X and Y, and then obviously we also want to influence a little bit our distance between our solar panels, and also give them basically an X, give them a little bit of an XY. Sweet. So we have here, for instance, let's call it an X count what we have, and then we have a dot dot. For instance, we have a spacing. Space ing for that. So what does this create? It actually creates one output, and I just click on the outside, and you see, for instance, here on the left-hand side, basically here spacing, and there's no 0. On the top again, we get a little bit of an error message here. Warning values used in this expression must be a number or basically a letter. It's a little bit complaining about this, but sometimes, yeah, you need to tell it a little bit. Be patient, Dynamo. I will satisfy, and I will help you in a second. And so what we can do now is let's create maybe a couple of sliders, similar like what we have just seen before. And let's say maybe we want to have some empty sliders. So maybe 1 up here, and then maybe we need to move this a little bit to the side. So you see, we can create some nice core logic. Then we copy and paste this again, and then we actually get here 3 sliders together. So you're probably wondering what this will be. Let's see what if the logic works. Good. Here on the top, be nice. Our interior slider, the top one. Let's call it, maybe it's our X count, and accept it. Okay, come on. Don't you want to accept it? Yeah, and accept it now. Yeah, very good. And this on Friday afternoon. Sweet. So then we have maybe a little bit of a spacing. What we want to have in between, accept it, and then double click it. For instance, let's call, for instance, here a Y count as an example. And come, do you want to accept it? Thank you. Good. So, and now we need to do with our Explore code block here, we just would need to, let's say, copy this. And this might be not our X count with the spacing. We actually copy this, and all what we do is now I just click into this here and just rename this basically with my Y. And you see also that this now changed here to my Y, which is pretty cool. All right, good. And then what else do we have? We have another one where we have another X count and another X count for that. Good. And then we have another X count around this, what we want to do, and another Y. So we actually get 4 points by points basically together. So, and then we can actually start here connecting our sliders with our code blocks. However, we have here our offset we actually want to work with, and you see when we just replace this, we get here another node here on the top, and then we can just offset, and then we can wire this up together. So brilliant. So we see here, for instance, another code coming up. Good. And so we have, for instance, a connection now here from the X. We go to our X count, obviously. We're going up here, and then we go from our spacing. We connect this here with our spacing, and this one with our spacing. And all of a sudden, you see that they actually work together. We go here. We connect, obviously, this with our Y count together. Good. So the other one is the X count and the spacing. We bring this up here again from the top, and then we go here our spacing together here. And then we do this the same with the Y as well. For instance, we have our Y count together, and then we have our spacing actually together here. Okay, so having basically offset. So we get a point here for 2 points basically we define then our panels with. So our trick is now here that we need to still satisfy here our offsets. And here I want to show you that we can also do some simple mathematics, some simple multiplication. And this would be, for instance, here some simple multiplication. We can just start it, and we see a simple operator, and click, for instance, here on our XY operator we want to have here. And then we start here with our spacing, let's say maybe in the X. And then why not, let's add maybe just another code block to that. And let's say maybe a code block, maybe just deal with another number, 0.5, that should do the trick, and then connect this basically together. And then all that we need to do is we just deal a little bit with our offset. So now everything is great, basically it's been certified. Looks a little bit like a wild laboratory here, but all what we need to do now is we actually just can now wire up here our ones. For instance, we go here to the X and to the Y, for instance, here on the top, and here on the bottom one, we go here, for instance, to the X, we go here to the Y on the top, and then see what we actually have here. Sweet. So we just have a 1, 1 now here on the bottom, obviously. So we see also here the second dot here in the back. Good. So I probably would need to switch a little bit to a different point. We see these two points. We actually a couple of points. We have actually there's some couple of more points actually already. We have created here in the back. So let's just quickly rotate this around here. Just so you get a little bit of a better view here. And so sweet. So 1, 2, and a spacing there. So when we now go maybe here to our X count and just slide this up a little bit. Oh, spacing might be a little bit harsh, so probably would need to update the spacing here a little bit. Probably not to 6. Let's say we want to go maybe to 5 here. Let's say maybe here we want to hit to 5 here. And the other one we probably want to limit this to 5 as well. Then we see, for instance, here should we see our points and our dots for that. Good. So our list is still missing. That's there. It's the part. Now it's now I was confused. So we have our 3 dots, and here's our list. This is the troubleshooting. You see, when we do sometimes we need to do a little bit of a troubleshooting, and this was just absolutely live. Oh, very good. So and here we have, for instance, now our 3 panels as an example. But I'm actually a little bit wondering why we have just these 3 here with offset and with the code together. If I created here a little bit of a mess, okay, then this is we see, for instance, when we now troubleshoot as an example. So it's just pretty live here that we get here a little bit of an error message. Good. Just to demonstrate, after we did a little bit of a troubleshooting, we probably figure out that I have saved this prior. That's pretty good that I saved this prior, because I can just quickly open this up, and at the end of the webcast, at least let you see a final example for that. Good. Another option is, of course, when we create this, that we do we have maybe here the points, I believe, do we need to have actually a cross product? Just have a, before I wanted to shoot it, let's say maybe cross product here, and let's say maybe here cross product of my points like I did actually before. Good. And then, there's a little bit something happening, which is good for that. And so then we have here cross product, and then I have here one going up here for that. We have a radius point, and then we see, for instance, here our list of my different points here. That's why we get my different points. Now we can do here a little bit of a troubleshooting. This is one point here from that, and then it's the other point, the other 2 coming up there from. All right, and now we have here the X count, and then we have here spacing there in between. Probably reduce this so it's a little bit easier. It might be that it's just too much out of the screen. So, down there we have it. Very good. Now come, be nice. Very good. So, for instance, here now we see here on the bottom actually our geometry we have created. So I don't need to open my saved version just to demonstrate that it should work. So we just managed to troubleshoot. And now when I, for instance, move here my son, we actually see how we have here simple interaction with these panels, and how actually these panels actually follow. They can play this the whole day. Fascinating. Absolutely fun and fascinating what we have here for that. Good. For that. So, and we see, for instance, and what do we see here? Just as a little bit of a punchline, we see this actually also happening here in our Revit environment. For that, and also in our Revit environment, that they actually should follow us. So let's shade this a little bit, that it looks a little bit further. Dynamo, thank you very much for today. We just move this a little bit to the side here. And now, when we are here, for instance, in Revit, we see actually here our panel, just somewhere in the sticks. And now we see it here, how they actually then update here also with Revit for that. So you see that we can create some really nice, cool logic with it. I thank you very much for attending, and that just be notified, guys. We have a training around this where we have a couple of more examples. You can, of course, look into creating just some structure. You can create anything, exchange anything with everything, whatever you love, whatever you like. Important is that you saw a little bit how we actually develop software, how we develop the logic here, and Yeah, so if you have any questions, just give us basically a ring, just fire through an email to support us, or whatever you love, whatever you like, and we try to help you out. But the best thing, obviously, would be also if you wanted to, yeah, just come around and where's our cool slide here, and visit our training. Okay, so have a wonderful, great weekend, and I thank you very much for attending this. Cheers, bye-bye.